In our previous discussion, we gave an example, functions that are differentiable on its domain or at a specific value of x, and also function that is not differentiable but it's continuous at that particular domain. So this time we give another example. Let f of x be equal to the absolute value of x. Is f differentiable at x is equal to 0? So if the question goes like this means that we need to find the derivative of the function. So we can say that a function is differentiable if the derivative of that function exists. So to find the derivative, we have this formula. This is the second formula for finding the derivative using its definition. So we need to find the derivative at x is equal to 0 because we are asked if f is differentiable at x is equal to 0. So f prime of 0 is equal to the limit of f of x minus f of 0 over x minus 0 as x approaches 0. So again, since a formula is our guide, so all we have to do is to follow this one. So we have limit of f of x. What is f of x? The f of x is absolute value of x minus f of 0. So all we have to do to get the value of f at x is equal to 0, we are going to substitute 0 to the absolute value of x. Then this is the answer. So we have limit of absolute value of x minus absolute value of 0 over x as x approaches 0. Obviously, absolute value of x minus absolute value of 0 is absolute value of x over x. So we have limit of absolute value of x over x as x approaches 0. So we have to take note. Now, what's more interesting here is that the absolute value is defined as like this. This is a piecewise defined function. So we have absolute value of x if x greater than or equal to 0, then negative x if x less than 0. So absolute value again is a piecewise defined function because it comprises of two expressions over a specified domain. So what are you going to do? Since this is a piecewise defined function, to determine the derivative, we need to find the limit of the function from the right and also the limit of that function from the left. So we're going to get the left hand and the right hand limit. So f prime of 0, which is equal to the limit of the absolute value of x over x as x approaches 0 from the right. So what would be the um, equivalent for absolute value of x if we are going to consider 0 from the right? So let's go back to the definition of absolute value. 0 from the right, this is x greater than or equal to 0. So therefore, absolute value of x in this domain is x. Okay, x. So this means that absolute value of x from the right, this is x over x, and this is equal to 1. On the other hand, f prime of 0 is equal to limit of the absolute value of x over x as x approaches 0 from the left. So we're considering the values from the left of 0. So in other words, this absolute value, by definition of absolute value, becomes negative x since the values are from the left of 0. Negative x over x, which is equal to negative 1. Now, since the limit of absolute value of x over x as x approaches 0 from the right is not equal to the limit of the absolute value of x over x as x approaches 0 from the left, or the right hand limit is not equal to the left hand limit because the limit of this expression is 1 and the limit of this is negative 1. So they are not equal. Then it follows that the two-sided limit does not exist. Okay? The two-sided limit does not exist because we have a theorem that for a limit of a function to exist, the left-hand limit must be equal to the right-hand limit. But since they're not equal, Thus, the two-sided limit does not exist. Hence, f prime of 0 does not exist, meaning to say the derivative of the given function at 0 does not exist. And since the derivative at x is equal to 0 does not exist, therefore, f is not differentiable at x is equal to 0. Okay, is that clear? So, in this example, we were able to solve and to determine that the given function is not differentiable at x is equal to 0. So, hope you like this video and hope you learned this video, and keep on sharing this, keep on sharing the learning that you've got from this video. And thank you so much for watching. God bless.